In this project I developed a software and hardware kit, designed for home security. The system controls a zone of interest, and when detects an intruder, notifies the user. In this prototype, intruder detection is obtained using a PER sensor. The system is composed of many software and hardware components. The hardware is composed of some actuators, sensors, and a Raspberry Pi, where the software components take place. The Raspberry also has the software components necessary to control an IP camera. A PER sensor can be attached directly to the Raspberry or on other wireless modules, like the ESP32 or ESP8266. Because the system is designed in order to be easily scalable, and the software modules do not take into account the physical connections of the devices. The software of the prototype is developed using the microservices architecture, so it is composed of loosely coupled independent software components. The communication between microservices is implemented through RESTful APIs. In this prototype there isn't a microservices container and a load balancer. Distributed transactions are avoided and strong consistency is not guaranteed. All the microservices are developed using the same technology stack. Each microservice is a web server on top of Cherry that exposes RESTful APIs. The business logic rules are in the Cherry action methods. The data access layer is built on top of Pony, which is a simple Python object relational mapper. The data persistence layer is composed by a SQLite database, which is zero config ratio, serverless, compact and one-file database engine, so it is good for constrained device and IoT applications. The presentation layer is composed by an AngularJS single-page application. Onsen is used as a user interface design framework. ONSys is a CSS and JavaScript framework which provide many user-friendly and mobile-first reusable web components, and it is well integrated with AngularJS. The web application can be compiled to a mobile iOS and Android application using Monaka, a cloud software as a service by Onsen team. There are 7 microservices and other scripts that manages the actuators and the sensors. The service catalog provides HTTP REST APIs for service registration and discovery. Each service is a microservice and has an unique key which is used as a search registration key. Services host and port are dynamic and must be requested before every request, because services can be started, stopped or restarted. Service catalog also manages the devices and their exposed endpoints. The registry service contains data related to the application. Its APIs are exploited by the client applications, and most of the data can be managed via the user interface. In the left column we have the client application that we can use in order to configure our system. In the right column we have the device connectors for the peer, the magnetic sensor, the buzzer and the IP camera. We can start the script which runs in the Raspberry Pi. As we can see, the devices can't send the keep alive because the service manager is not running. Then we can start the service manager. The devices request the broker endpoint and starts to publish messages. Now the service manager successfully receives the keep alive from the devices. If we try to register a new user, an user-friendly error is shown, because the registry service is not running and it manages user data. We can start it and register a new user. The registry receives a post request and stores the user. Then we can configure our places. Then we can add devices to the room. The system proposes a list of viable devices that are not yet assigned to any room. When the devices are added, the topic where the device published change, adding a reference of the house and the room where it is registered. Clicking on the device, we can see its functions. Now we can log out and log in order to see if everything is as expected. We can configure other spaces, but we have not enough devices. So we can configure our alarm zone in order to activate our control strategies. This data is managed by the registry service. The event manager exploits its API, and when an intruder is detected, if a zone is alarmed and a camera is found in the same room, a snapshot is taken, stored and sent to the Amazon Recognition API. The API response contains the detected labels in the image. If they are human-related tags, the alarm is considered as a true positive, and the user is notified by an email message containing the alarm zone name where the event was fired. As we can see, the devices are publishing in their topics. We can log in and activate the alarm zone in order to activate the Event Manager control strategy. The registry service receives this request and changes the activation status of the alarm zone. Then we can start the Event Manager control strategy. Suddenly it starts to receive the readings of the peer. If I move my hand in front of the peer sensor, it detects my movement and requests a snapshot through the IP camera. In this case, because I am in front of the camera, the Amazon Recognition Service finds a human, and the alarm is considered as a true positive. An email is sent to the user, which owns the alarm zone, and the buzzer is turned on. The magnet strategy is another control strategy that raises alarm events when both the peer sensor and the magnetic door sensor detects presence during a short period of time. We can start it. It receives the readings of both the peer sensor and the magnetic sensor. If I activate the peer, it receives the notification and stores this event. In this case, the alarm was not triggered because the magnetic sensor did not detect human presence. The same happens if only the magnetic sensor is activated. But if the two sensors detect human presence during a short period of time, an alarm email is sent to the user without considering the IP camera. The buzzer is turned on.